So section 5.3 means sum and the finite integral. First of all, let's check what's the Riemann sum. We already did that last section. Let f be a definite on a closed interval AB. So we have interval AB, and let delta, which is the width for each rectangle, because we're going to divide the area to sub-interval. So the delta is a partition of AB, where delta is going to be, you see the partition, this is the first one, the second one, the third one, until the last one, which is the value of B. So here is the interval from A to B. Is the width of the I plus N sub-interval. Here's our interval, it looks like here is A and here is B, and you divide the interval to these sub-intervals. The width for each rectangle here is going to be delta. If C is a point on I plus N sub-interval, then remember that we took this one last class, which is the summation of, this is what? For the rectangles is what? This is the width for every rectangles. This is the length. Remember that? We did find the area between curve and the x-axis. So we're going to divide the area to sub-intervals. And here is the rectangles. The length for each, here is the point C. So this one is F to the C. That's mean this is the width for this rectangle, and here is the length for this rectangle. I have length and width. I can find the area for this one. What about if I need to find the area for each rectangle? I'm gonna say the length for each rectangle times the width for each rectangle, but I have to do the sum. The sum for the first rectangle plus the sum for the second rectangle, and keep going. So this is the sum for all rectangles is going to be, is called a Riemann sum. Again, our rectangles go into infinity, because I can do 100 rectangles or 1,000,000 rectangles to find the exact area. Every time I maximize the number of rectangles is going to be, we're going to close to the exact area. So if we took the limit for all the rectangles, we're going to go exactly to the area, but I have to take the sum for all the rectangles, and then I have to take the limit. Everything here, we can convert that to the integral. Integral, we have the interval from A to B, so it's going to be integral from A to B to our function, which is already, we have the function, times dx. That's mean, and instead of doing the whole thing here, we're just going to take the integral from A to B f of x dx. This is called the finite integral, because it's integral for just this interval from A to B. So instead of using limit and sum for all the lengths times all the width, we're gonna do the integral from A to B to find the area. And that's what's gonna happen next one. So to find the area for a curve and x-axis or y-axis, depends on how you're gonna find the area. Let's see the next one. We're gonna use the finite integral as the area of region. So you see the area is going to be from A to B of x dx. And be careful. If you are finding the area between the function, which is the curve, and what? X-axis. And x-axis, you're gonna divide, sorry, you're gonna say dx. If it's for the y, like our rectangle here, is going to be like this. This is the area. Our rectangles on x-axis, okay? This is the rectangles. I'm gonna do rectangles like this. On x, we're gonna do dx. But be careful, if we have like this, and I need to find this area. it's not on the x-axis. I can't grab the rectangles like this because here's the curve. I'm going to grab the rectangles like this. So the rectangles on which coordinate? On the y. So you're gonna say, well, dy, okay? We're gonna check some examples here. So look to the rectangles, it's on the x or on the y? We're gonna set up the integral. So look to this example. They give you already the area, the graph, sorry, and they ask you to set up the integral. First of all, the function is f of x equal 6 minus 3x. So all the function is written for the x. That's mean, if I look to the graph, can I write down the graph, the rectangles like this? To the x? I can. One rectangle, here's the second one, third one, and keep going, because I need to find the area here. That's mean, if I need to set up the integral, it's for dx. So I'm going to look for a and b with the x coordinate. From which point our graph to which point? From 0 to 2. So I'm going to put 2 here. I just need to set up the integral. My function is what? Here's f of x, which is 6 minus 3x. That means I need to do the integral for this function with respect to the dx. That's it. Our goal is to set up the integral. They didn't ask you to find the area. We're going to do that next section. That's why I'm going to finish this section and jump to the next one. Any questions for this one? So look, you're gonna say, I'm gonna graph it with respect to the x or the y. The rectangles on the x or the y. To the second one. I'm not gonna, because here's my function. So here's the function. I already going to write down the function here. That's my goal. Now I need to find the area. You see the shape area from, can I grab the rectangles like this? You see if I divide the area. So with respect, my integral is going to be with respect to the x. So here's the dx. From -2 to 4. Just going to type 4 here. So here is our integral. If you need to find the area, you have to find the integral here. And let's go to the next one. Is that the same thing? Here's the function, which is, I'm going to type 25 minus x squared. And I need to find the shaded graph. Can I grab the rectangles like this? So from -3 to which point? To 2. So from -3 to 2. So our definite integral from -3 to 2. And here's, we just set up everything because our rules is set from a to b, f of x, dx. That's mean the integral from a, which is, we need to find this area from -3 to 2. We're going to write down our function, which is a 25 minus x squared. And then, okay. Jump to the next one. What about this one? Then our function is f of the x equal cosine x. And I can divide the area to these rectangles. That's mean with respect to the x coordinate. So the integral from a to b of x with respect to the dx. That's mean the integral from which point? From 0 to pi over 2. And our function is cosine x dx. That's it. That's our definite integral. Let's do it again. The integral from a to b of x dx. The integral 0 to pi over 2. Our function is cosine x dx. Now, what about this one? Two things you're gonna notice on this function, on the graph. The function is what? The y, you see, so it's dy. Now, if you look to the graph, can I graph the rectangles with respect to the x coordinate? You can't, you see, because the curve is here, and the border of the shape here until 2. That means I can't graph the rectangles like this. The only way I'm going to graph it graph the rectangles like this to the y. So that's mean our integral from a to b is going to be f to the y dy. Not with the x. The integral is going to be from y equals 0 to y equal 2. From 0 to 2. And my function is y cubed. Okay, so keep in your mind, when you're trying to find the integral with respect to the x, it's going to be dx. When you're trying to find the y, the integral with respect to the y is going to be dy. And your function is going to be with respect to the y, not the x. You can't find the integral here and everything with x and then dy. It's going to be different type of integral, like x is going to be constant, and that's what you're going to learn on Cal.2, okay? We can do the integrals with respect to the x and the y. That's mean, without looking to what they're telling you here, you can graph the rectangles on the x and the rectangles on the y. That's if you have the function, but look to the function is written to the y. So the only thing I can do here with this graph, I can write down or graph our rectangles to the y, because our function is with respect to the y. That's mean the integral from a to b, f to the y dy. So the rectangle from a equal 0 and b is 2. So from 0 to 2, and the function is y minus 2 squared dy. This is our definite integral. Example. That how we need to set up the integral. Our rectangle is going to be, you can grab it like this. So from the integral from 0 to 2. So from 0 to 2, and our function is 8 e to the negative x. That's it. That's how you're gonna find the area. So the area is going to be equal the integral from 0 to 2, 8e to the negative x dx. Let's see, which one is the right graph? Determine scratch the region whose area is given by the definite integral. So here's our definite integral. So I already know the rules. It says the integral from a to b and f of the x dx, okay? If I need to sketch the graph, where's my function? Where's the function? The integral from 0 to 3, the integral from a to b, and dx, here is dx. So where's the function? F of x equal what? 5. It's a constant function. So f of x equal 5, that means y equal 5. So here is 0 and here is 5. So here is y equal 5, which is a constant line. Now, the integral from 0 to 3, that means x equals 0 and x equal 3. So x equals 0 and x equal 3. So here is our graph from 0 to 5 and from 0 to 3. This is what? Can I find the area? It's not a curve, it's a rectangle. We can't say it's a square. Why? Because check, here is 5 and here is what? 3. So how are we gonna find the area?
Length times width.
Which is, let's say this is the length, that's mean 5 times 3, so equal 15. If they ask you find the area, because it's geometric graph, we can find the area without using the definite integral. Again, if you're going to use the definite integral, it's going to be right. The result should be 15. And that's what we're going to learn next section. Any question about this one? You just choose this one. Check the other one is the opposite. Use geometric formula to find evaluate the integral. Now, what about this one? Don't look to the graphs. First of all, we need to, our function is, I already know x from which point?
0 to 4.
X from 0 and x equal 4. Now, my function is f of x equal 2x plus 3. Now, let's look to this graph. I'm not sure this is the right one or no. But if I look to the x from 0 to 4, and my integral with respect to the x. So from 0 to 4, if I look at this graph, it's from 0 to 4. So the x is right. I need to check the y. That's me. If I need to check the y, which is this line, I have to graph the line. How are we going to graph the line? Don't look to here. How are we going to graph the line to make sure this is the right one? X and y. Choose the 3 points. 0, because we started from 0. And let's choose 2, 0, and x equal 2, and x equal 4. Now let's plug in these points and to find the y. If I plug in 0 here, 2 times 0, 0, plus a 3, that's mean y is going to be 3. This is right? Look here. When x is 0, how much the y? 3. 1, 2, 3, 4, 5. So the y is 3. This is the right point. When x is 2, plug in 2 times 2, 4, plus a 3, 7. Let's look. When 2 is going to be what? So is this the right one? 5, 6, 7. Plug in 4. 2 times 4 is 8, plus a 3, 11. So when 4, here's the 10, this one 11. Does that mean this is the right graph? This is the right one. You're gonna choose this one. Okay, so it's telling you the coordinate for the x from A to B. You just have to graph the y to get the right graph. And they're telling you the formula is what? This is the first height. Again, h1 plus h2. You're gonna multiply by the base, which is and divide by 2. That means the first height is 3. The second height is 11. You're gonna multiply by the base, which is 4, and divide by. So this is the formula to find the area when you have the trapezoid. Next one. Hash the graph. You can tell. First of all, I have absolute value here. That means I have negative and positive. Because our absolute value is negative x and positive x. But look to the coordinate for x from negative 5 to 5. Is that from negative 5 to 5? Let's see the other options. This is from negative 6 to 6. This one is just the positive side. So what are we gonna do? So this one is going to be the right one. That's it. Again, how are you gonna find? Do you have geometric formula to find the area for this one? Not this one. This one. It's what?
Area of a triangle,
Which is
1/2 base times height.
the base. Be careful. The base not only this part. The base is going to be from negative 5 to 5, which is what? It's 10. The base here is 10 units. I know I have negative numbers here, but the length for the base is what? 10 units. So the base half the 10 times the height is 5. Okay? So it's going to be 25. What about this one? Don't look to these two graphs. But I'm sure none of these two options. Perfect. It's a circle. It's a circle with the center is 0, 0, and radius is what? Yes. So it's a circle. This is a circle. Now, what about if I have square root? That means what? It's what? Now I know this is a circle with radius 36. What about if I have square root? What does that mean? I have what? I have half circle. So this function is half circle because this is the circle with center 0, 0 and radius equals 6. So my graph should be what? Should be half circle because I have only y equal. And again, to plug in any number here, the result is going to be what? Positive. Plug in any number here, the result is going to be positive because we're going to square this one, square. That's mean. We're going to go back here. All the graph is going to be well on the top. So our graph is going to be what? Half circle. Let's check that. Do we have half circle? There we go. Of course, this is going to be wrong. This one is a circle from negative 6 to 6. Now, what about how we're going to find the area when we have circle? Half squared pi, that means the area here, because they ask you to find a formula and they're telling you A is greater than 0 or greater than 0. That means the area is half squared pi. This is then The area is going to be 6 squared pi, and be careful, area equals 36 pi. This is if we have a circle, I need to find half of the circle, we're gonna divide it by 2, so it's going to be what? 18. So which example this one?
12.
Example 12. So this is already given. All this information they give it to you, and they ask you to find what? The integral from 4 to 8 negative 9x dx. And that's what we're gonna learn in the next section. But now they give you these options. Now, don't look to the 4 and 8. Keep it on the end. As integral, how I'm gonna find the integration for negative 9x? Don't look to the integral. This is the last part. How I'm gonna find the integral of negative 9x dx? Can I move negative 9 outside the integral? So can I say it's negative 9 integral from 4 to 8 x dx? I'm telling you, that's why it's a stupid question. So here's negative 9. Do I have this amount? Do I have the integral from 4 to 8 x dx? They're telling you here. From 4 to 8 x dx equal
24.
24. That's mean I'm gonna substitute instead of everything here times what? 24, and the result is going to be negative 9 times 24. That's it. Is that hard? You got it? Or you lost? Let's see this example. We're gonna do exactly the same thing. So this is already given. My goal is to find the integral from 4 to 6 x minus 13 dx. Again, don't confuse yourself about 4 to 6. This is the last part. It just look like without this root. Order from 4 to 6. So our goal is to find the integral from 4 to 6 to the x minus 13 dx. Now what I'm gonna do the next step here. Can I separate these two integrals? Can I say is this one equal the integral from 4 to 6 to the x dx minus 13, the integral from 4 to 6 dx. Yes or no? Now let's check the first one. The integral from 4 to 6 x dx, how much? The integral from 4 to 6 x dx equal? So I'm just gonna put 10 here. Here's the minus, and here's 13 times. The integral from 4 to 6 dx is 2. I'm gonna put 2 here. That means going to be 10 minus 26, which is equal. You got it? And do the same thing here. So here is the information given, and they ask you to find the integral from 4 to 6, 2x cubed minus 11x plus 3. So the integral from 4 to 6, 2x cubed dx minus the integral from 4 to 6, 11x dx, and the plus the integral from 4 to 6, 3 dx. They move the numbers here, move the 11 outside the integral, move the 3. So this one equal to the integral from 4 to 6 x cubed dx minus 11, the integral from 4 to 6 x dx plus 3, the integral from 4 to 6 dx. Do I have x cubed? 2 times
Yeah, 260.
260 minus 11, the x is 10 plus 3 and dx is 2. I'm just gonna add these to the math. That's